Okay, hi everyone, and welcome to the 4D Method 4D user group. Today is October 2nd, 2024. This is meeting number 74, fighting number 74. On our agenda today, we're going to go back through and say a little bit about what the 4D Method user group is, talk a little bit about our long list of upcoming user group presentations. We'll get a quick review of recent 4D happy hours from Kirk Brooks, and we'll get some news from 4D themselves from Jim Sobczak. I'll review a couple of recent 4D blog articles, and then we'll have a section called "Of Note in the Knowledge Base," where Ad will highlight a few recent tech notes. And then hopefully we'll get our big presentation today from the top folks at Sweetwater Sound. It's called 4D times faster, automating 4D deployments using Gitlab CI/CD pipelines. It's James Scott and Jeff Kain. I see Jeff just popped in, and James as well. Thanks, guys. Hopefully everything is okay on your side. But yeah, we'll get to that later. My name is Brent Raymond. I host these user group meetings. It's a great platform for all of us 4D users and developers to show a few things off. The website is 4dmethod.com. I can be reached at 4dmethod@gmail.com. I've been a 4D developer for as long as I can remember. I'm a not only a 4D advocate, but I'm a user as well. I like to see how everyone else uses the 4D development platform. I always find it interesting. It's yeah, as we mentioned earlier, we're into the 70s now. Not back to the 70s, but into the 70 something presentation here, and they just keep getting better. So yeah, so what we like to do, why we do this user group meeting is just to bring together the scattered community out there of 4D developers around the world to show some of their programming techniques using some of the latest features and not necessarily the latest features, just to see where 4D is deployed in the world, what it's doing. It's always involved in different industries, different purposes. I for one find it very interesting to see what people have been able to do with the language and the platform and all of their applications. And just to get some great ideas for yourself, to see how other people manage their applications and their pipelines and big operations like Sweetwater will, I'm sure, inspire all of us. And just for anyone who's new here, this is your 4D support community right here, 4D user group. It's all of the best talent in the 4D world, and feel free to reach out to any of the people that have presented here to the user group if some of their ideas spark an idea for you. All of our meetings are open and done live on Zoom, as pretty or ugly as that may be, we do it live. So yeah, so anyways, we have a great list of presenters coming up. On November 20th, we have Juan Carlos Perez doing a presentation on dynamic query utilities. And January 22nd, to start off 2025, we have the maestro himself, Keisuke Miyako, doing a presentation on offline updates and two-way synchronization in Orda. That's bound to be very interesting. Some of this technology started off with 4D for mobile for handling offline updates with mobile applications. And he's going to show how the same kind of approach can be used with standalone 4D applications or just any other use where you're trying to sync data between two separate locations. And then on March 12th, we're going to have our first deep dive into 4D and AI. Ricardo Mello will do a presentation called Bring the Power of Large Language Models to Your 4D Applications. So that's going to be very exciting. You know, that's hit the world like a storm. Hopefully not like the hurricanes we've had here recently. Hopefully all of you are out there staying safe. But yeah, you can see all of the upcoming schedule at 4dmethod.com/schedule. And what about you? We'd love to see your name on the schedule. You know, it's amazing that that we've had so many meetings and we still keep having new people, new faces show off their work. We've also had several wonderful repeat presenters for the user group. It's an easy crowd, and we're all excited to see what you have to offer. So if you'd like to pitch in an idea, reach out to me and with a topic idea, topic name, title for your presentation, and we can take it from there. We have one open date, but the rest of the year is entirely open. For next year, we have April 30th. If you have an idea for that, let me know. Otherwise, we'll put together some more dates for the calendar, and you can have your pick from those. So, all right, I'm gonna pitch it over to Kirk Brooks to talk a little bit about the weekly happy hour, 4D on Tap. And what's been discussed recently.
Thank you, Brent, and hello to everybody out there. 4D Happy Hour for anyone who's watching this who doesn't know about it, because I see a great majority of the folks on the call already have stopped into Happy Hour at least sometime. Is the weekly 4D informal 4D tech session that I host. It's 3:30 Pacific time every Friday. We typically go for at least an hour and a half, 2 hours, sometimes longer. And it's an opportunity to come and frankly just really nerd out on 4D. Prior to the meeting, we were talking about, we were discussing art and then kind of commenting on the fact that, you know, in contrast to programming, there are a few places where you can just go and say, hey, look at this, isn't this cool? And have people either explain why it's not, or go, ooh, that is really cool. And of course, ask the questions that are endemic here in the 4D world, like, why would you do that? Or why did you do it that way? Or the thing that frequently happens in 4D Happy Hour is just someone say, I never knew you could do that. And that's really turned out to be, I think, one of the great benefits of sharing screens and just having an opportunity for a little open collaboration and discussion of the technicalities of 4D, of the business of 4D. If you've ever considered being a developer or working as a developer or working with a developer, this is a place where you can come and actually talk about that and ask questions like, how'd you get started? Or, you know, what do you do? How do you, you know, how do you do that? It's the HDI for the business of 4D, I suppose. And recently, we've been having a number of good discussions. For the last several weeks, I've been diving into user permissions and roles, privileges, how in the realm of a 4D project, we handle both the authentication of a user and the authorization of a user. And specifically, I've been educating myself and spent some time talking about the material that 4D has produced about that. Most of it pertains to web sessions, but more and more of it is starting to be applicable in a client server setting as well. And so those have been pretty interesting. Tim Neville's was, has just recently gone, wow, classes are great, and was sharing some of his excitement about that on Friday. There are folks who are wondering what's the big deal about classes. Stopping at a happy hour is always a good discussion to have. Just ask the question and see what other people have to say, and then of course the great part is sharing screens and just seeing what other people are doing with it. The opportunity to try things out. I dropped the Zoom link in the chat. It's come and go as you please. Feel free to come in regardless of your level. There are some of us who have been doing 4D for 40 years, and there are folks who show up and have been doing 4D for a relatively short period of time. And again, this is one of the few places where you can come and just kind of hang around and ask questions. So, and get ideas. So it's open to all. I encourage you to stop by and say hello. And with that, Brent, I'll toss it back over to you.
Thanks, Kurt.
Let me make a comment about happy hour. I started doing 4D work in 1990, 34 years ago, pretty much full time that entire time. Maybe a handful of 40 happy hours, less than a handful of 40 happy hours. Have I not learned anything about 4D? Not learned anything. Every time I pick up something new, some new way of doing it, really, you can do it that way? I didn't realize that. I do it this way. You're going to pick up a lot of stuff. So there's some people here that they consider themselves 4D experts. I consider myself a 4D expert. You come to happy hour and you're going to realize, wow, there's a lot I still don't know about 4D that I can use in my day-to-day business. Come check us out. You're not going to regret it.
That's right. There's always something to learn, and I really like what Kirk said earlier, that it's like a HDI, how do I, for not only for 4D development but for 4D business. For being a developer, you get very seldom do you have direct access to people doing this for a living and making money off doing this, and finding projects and how they navigate those channels. So thanks again for hosting it every week, and for the great idea of having the 4D happy hour, Kirk.
Happy to do it.
All right.
Kirk was also full of great jokes, so that's worth the price.
worth the price. All right. And now I'm gonna hand it over to Jen to see a little bit about what's the news from 4D the corporation, 4D Incorporated.
Yes, thank you, Brent. Hi everyone, and welcome. Thanks, Brent, for inviting Ad and me to participate in this meeting. We both think it's a great opportunity for us, and it's always good to see everyone in this meeting, and some new faces today, which is pretty awesome. So today I'm going to keep my part short because I want to leave as much time as possible to Jeff and James for their presentation on automating 4D deployments, which would be pretty awesome. So as you all know, Sweetwater has been a great 4D partner for many years, at least as long as I've been with 4D, which is since the year 2000. So we work with their team every week. We have meetings with them, and it's just incredible what their development team has accomplished. 1,200 concurrent users on their production server, but much more than that. I mean, just the way they've architected their entire ecosystem with 4D there. Even their coffee shop, on-campus coffee shop, runs on 4D. So it's pretty cool. And they've been gracious enough to have us, the 4D team, on site and several occasions. So we're looking forward to do that again this year. So, so I know that Brent has a few slides about what's coming up in 4D 20 R6. That release will be happening soon, as will 4020.5 LTS, both of which will be certified for macOS 15 Sequoia, and also the latest release of Windows 11 24H2. So yeah, so keep your eyes open for those release dates. I just saw a new post on the blog just before this meeting from Matthew Ferry that 4020R6 is when Codely Studio for 4D officially goes beta for all developers. Most of you know who have worked with Codely Studio for 4D. It's been in developer preview since the release, but with 4020R6, it will go into beta. So that just gives you another reason to move to project mode if you're not there already, and embrace the coding with 4D classes. So it was pretty exciting news when I read that today. And with the new releases, it always means we have a new release webinar on the horizon. So the release webinar for 4020R6 is scheduled for November 7th with Will Taylor and Ad, who's on this meeting. So we're going to continue to use the new format that was really successful in the last meeting, which means more demos. So we got really good feedback on the latest release webinar. So we're going to continue with that on November 7th. So, and then a couple of announcements from marketing. Keep your eyes open for another update on a campaign that our marketing team is releasing, focused around mirroring, and how our professional services team can assist you in setting up a mirror if you're so inclined. I know many of you are already using mirrors. They've been available for a long time, but I think we have a better process for doing that now. So you'll be reading about that more. And we're also working on a new 40 partner landing page, which is really exciting. And you'll be reading about that more soon from our marketing team. So I think that's it. I always like to remind people about on-demand training. I think the newest training that you probably read about is this three-step program on advanced training around ORDA. It's 3 separate trainings. Actually, you can purchase in the 4D store, and we're getting really good feedback on those too. It's kind of a follow-up to the ORDA beginning training. So this should be pretty awesome.
And these are new courses, Jim? These are brand new, never been offered before.
No, I don't know. I know, Tim, you asked me that. I'm still trying to get feedback on that. I don't know that they're brand new.
But
I'll
if
check
you
on
offered
that.
if you offered them in the past,
Mhm.
I've probably already taken them, but I've forgotten them. So I just need to know, have I taken them and forgotten them, or I've never taken them?
Well, if you took them and forgot them, you should probably sign up and take them again.
Yeah, I know that sounded really bad when I said that. But anyway, I don't want to take it again if I've already taken it.
I got you, and I'll find out to make sure.
Thank you.
But yeah. Okay, I think that's it for me, Brent. Thank you for the time, and looking forward to the presentation.
Well, thank you, Jim. And it's always good to get a little inside scoop when we can. That being the Codely going to beta, which is very exciting. A lot of development efforts being put towards that by 4D. Big steps forward, and yeah, no, it's you know, if you're not mirroring one way or another, it's the way to go for backing up. As JPR used to say, or still says, you know, one backup is no backup. So you should be mirroring and backing up, and then maybe backing that up. So that's always a great option. Especially it's nice now that 4D is offering that as a service. So we don't have an official release date, I guess, for R6 quite yet. So we're just
Correct. We do not.
Okay. But I know that's coming up very soon according to the timing. We're developing on the R6 beta this time around at the Art Institute of Chicago Museum where I work. So we're excited for that release and for all the features that are coming along with it. Speaking of those, in this case, we've got a little list of highlights here for 20R6. the support of singletons in the REST server and in Codely. It's actually pretty neat. You previously could see all of the data class functions from within Codely and in the REST server. I mean, Codely uses the REST server, so if you can see it there, you can see it in Codely. And now you can also have any number of singletons, which are just custom classes that are always available. You don't have to initialize them. They initialize once, and then they're good to go. Instantiate, I guess that's the word I'm looking for here. But yeah, it's nice to see those available from within the REST server in Codely. Also, HTTP agents. That's a new thing for all of the HTTP class usage that we're most of us are using now within 4D. Allows you to customize connections to HTTP servers, things like timeout, keep alive, and so on. And you don't have to again reconfigure those. You can just have an agent that is used with connections to said server, and then you don't have to mess around with putting those into your HTTP retrieval and any of the following calls. They're just already there for you. Shared classes between components. If you're using components in your environment, this is really nice because the components can see each other's classes. Previously, the host, the matrix application could see the component classes, which was new in itself in one of these R releases, but now the individual components can see each other's classes. So it sort of completes the class playground or interaction in the component world. Then we also have these simple comparison operators. Equals is not equals for comparing two objects or two collections. It compares on the what word am I looking for? Not just the contents, but the memory location. It's a way that you can be absolutely sure that you are looking at the same object. So any changes between two separate object variables or collection variables is going to affect the same object in memory. Reference. Thank you, everyone. The reference is the word that we're looking for there. Then we also have session storage by ID, which is pretty cool. Not just with web sessions, but also with client sessions. You can get access to any session one way or another by this new session storage by ID. So that you can make sharing session information more easily between all of those environments, which is a pretty powerful thing to be able to do. And I'll just blast through a couple more of these. There's now a user preference, compiler preference option for configuring what warnings you want to be warned about, which is nice so that you can only concentrate on the ones that, such as this function doesn't exist kind of warnings. So that's an important one. There's also the custom parameters file for web area init. It's 4D parameters for additional configuration for the Chromium engine, which is what the web areas run on in the 4D application environment. Then also the further step with the component management that you can just pop in a GitHub account and a name for a repository, and it could pull the latest one. You can also configure it with a specific version of a component, and it will automatically maintain that for you, which is great, again, for all of us who are dependent on components. And there's a lot of great shared components out there that a great way to share code for all of us. 4D Net Kit custom OAuth 2.0 connection dialog. You can design your own login screen. You don't have to use another, the source, the server that you're connecting to or authenticating against. You don't have to use their login screen. You can customize it and make it look like that you did all of that work. But yeah, it's nice for all of us with OEM or off-the-shelf applications to be able to handle that custom authentication screen. And then also some improvements to subform scrolling. I won't go into the details in that. All of those details best place to see all the details is in the blog, where there's, for most of these things, individual articles and how do I databases and sometimes videos. You can comment, and I can't remember. Is there thumbs up in there too? Maybe, but yeah. So it's all a lot of great stuff coming in R6, and I think there's at least going to be an R7, but we're creeping on up to the next major release, and where all of this becomes available in the dot releases. But currently, all of this is only available in the R releases. Speaking of the blog, a couple of other articles of note are looking at Codely Studio for 4D, what's new in 20R6, some of the things that we've already mentioned previously, but there's a lot more that they've been adding in each of the R versions to support Codely. Among them, I guess it's coming out into beta and out of developer preview. Then article with very specific detail on macOS Sequoia compatibility for 4D versions, and another article on PDF A3 attachment extraction. It's not just the ability to be able to create a PDF with files embedded in them, which is very important for folks in Europe. There's been some regulations recently about having invoicing, all of the information and invoices also available as XML embedded in PDFs. So it's pretty interesting. 4D obviously is early to the table to offer the ability to create those invoice PDFs, but also to extract attachments and have all capabilities necessary with those files. And right, as I mentioned earlier, there's a blog article on REST and Codely support of singletons. So, yep, that's a mouthful, but that is a lot of stuff coming out in this next imminent R release of version 20. So now I'm going to kick it over to Ad to talk a little bit about the recent tech notes that have come out in the knowledge base.
Thanks, Brett.
Yep.
Hello, everybody. And I'm back again with more of the tech notes releases. For this time around, I would like to focus on the previous two tech notes from August and September. But before I get into that, just as usual, I want to remind everybody that the knowledge base is publish many articles weekly as well as monthly. And especially for tech notes, it's a special benefit for partner people who are in the partner programs. You'll get the latest tech notes in advance than everyone else for at least 1 year. And we're trying to gather all of the different topics, whether it's beginners, advanced, anything at all that we can put together, making sure that it's beneficial to you for productivity or development. Anything that's within the 4D scope, we'll try to put everything out there. And also, most of the time, you will find that TechNote comes with an example code, a lot of free stuff that you can take and use in your own application or in your own project. Okay, so in August, Thomas Mall created a tech note about structure info class. So what it is a special implementation that he put together. Now that we have class, there's so many things that you can use classes for. And one of the things that he created was an ability to be able to read the information about your structure, table, fields, definition, all of them is implemented within a class. What he did was he created a bunch of function where you can just easily call and utilize some of the response, which is the result of those class function in any fashion that you want. But if you look inside the code, there's a lot more that goes on within each function of the class. So again, this is one of the use cases that you can use for for class in 4D. There are many other use cases as well, but have a look. Thomas always have some really great idea about how to use 4D effectively. Another one is about XLIF. Now, XLIF is nothing new in 4D. It's been around for a long, long time. And I know that not many of us have to deal with multi-lingual application. Times to times you have to because of the nature of the business requirement or the goal of your deployments. Now, if you find yourself that you have to create an application that will support or needs to support multiple language, this is the application, this is the technology that you want to use and follow. So my colleague Karim, I'm not going to butcher his last name, but I'm going to try it, Mekrawi. He was one of our senior tech support from Morocco, put together a very nice tech note, go over different details about how to use XLIF in 4D. He even create multiple example inside of the tech notes, and as usual, it comes with an example application where you can study from. So yeah, have a look at it. I think you'll find it to be somewhat either very useful or at least somewhat useful to your learning in 4D. Okay, so yeah, that's it from me, Brent. Thank you, guys.
Okay, thanks, Ed. I just couple other comments about these tech notes. It's even if you're not necessarily needing something like the structure info class, it's well worth a peek into the repository for seeing some other class code that might be worth stealing. I'll just say that, or borrowing, or sharing with yourself. There's some nice classes included in that repository that can give you some ideas for, say, how to use singletons and some nice code to introduce into your application as singletons. Yeah, and the XLIF stuff is definitely cool. I mean, it's a lot of work to create a multi-language application. That's definitely how you would do it. I've long thought it would be nice to have the ability to switch languages for some of our users at the museum. And not only that, but for any of us that have products that we license out, then that's an obvious way to open up your business to more clients. So yeah, interesting. Both the articles are very interesting, and thanks, Ed, for your team's effort with all these nice publications. All right. And then, whoa, where did that go? I think I might have crashed Keynote there. All right, here we are. All right. So getting to the good stuff here. I'm thankful for I've really wanted to have these guys and see more from Sweetwater, and so it's great to have James Scott Jr. here today and Jeff Kain here with us from Sweetwater to tell us how they a little more information about how they manage such a big operation, such a big application environment at the company, which is used in so many different ways there. Just a little bit about both these guys. If you'll bear with me, we normally have one intro, but gotta share a little bit of information about both of them here. James has worked as a technical thought leader in the IT industry for 50 years this November, which is an incredible career. Happy birthday, happy anniversary. That's quite a lot of experience to offer. Having worked with many industries, James has a deep understanding of the contributions technology can make to an individual's personal growth. And yep, he says it's all about the human. So that's sure there's a wealth of wisdom there that James can share with us today and otherwise. Then we have Jeff Kain. Jeff began working with 4D in 1993 as a co-founder of Orchard Software Corporation in Carmel, Indiana, which is another real beast of a original 4D user for 4D production studio. Orchard's first product was a 4D-based medical laboratory management package that services all the needs of a modern medical laboratory, as they say in England. From phlebotomy, I think I said that right, and order entry to automated interfaces, to catalogs of hundreds of medical devices, and to integration with billing and medical record packages. It was a big and capable application, just like what they have at Sweetwater. And as a member of the management team, Jeff helped grow the company from 3 employees to over 250 during his tenure, including a staff of over a dozen full-time 4D developers. Imagine what all of us could do with over a dozen 4D developers at our resource at our companies. Then in 2014, Jeff moved on to Sweetwater Sound in Fort Wayne, Indiana, where he joined their IT staff to help manage and refurbish the largest single 4D server deployment in the world. Yep, in the world. Yeah. Following a similar playbook as he did at Orchard Software, Jeff helped grow the team from 2 4D developers to over 25 and was instrumental in stabilizing, modernizing, and improving the performance of this large legacy application, which continues to power Sweetwater's core CRM functions today. So it's all true, and we're excited to hear a little bit more insight into how they're able to over 1,200 clients. I just can't even imagine it, and such a large application. So welcome, guys, and thank you so much for being here to talk with us.
Thank you. Share my screen.
Yeah,
Okay.
thanks, Brent.
You're welcome. Go. Should be able to share now.
There we go. Okay. Can you see it?
Yes.
Great. All right. Thanks for that wonderful introduction, and thanks or hello to all the folks who've joined today. Some of you know that I am not a fan of Microsoft Windows, and I apologize up front for sharing a presentation slide that's based on Microsoft PowerPoint. But I had to do that in order to present it to a different group of people who didn't know anything at all about 4D, and I wanted to inform them as to how great this particular tool is. So in order to get through that gate, I had to use Microsoft PowerPoint in order to do that. But I survived it, and we were able to make some progress. So this is my agenda and Jeff's agenda for today. I'm gonna talk through this slide and then I'll let Jeff kind of give you some background. Um, but where we start is in our context of our CRM application. Overall, the fundamental thing that we're after is that little box that you see at the top of the screen. There's lots of ways to configure 4D and use 4D, but in our context, we're going to develop an application and compile it down to one file called the 4DZ file. So that's our target, that's our goal, that's the thing that we want to produce as frequently as necessary and deploy. So the population that I originally wrote this presentation for didn't know about the background of 4D and what it was capable of. And I had quite a few consultations with Jeff and 4D and everybody I could find. I wanted to try to describe 4D in one block diagram. And what I found out is the blocks aren't big enough. But in today's technical infrastructure environment, you hear a lot about Kubernetes, and you hear a lot about service modules and on and on and on. And what makes 4D unique is it is a full-blown mini computer or application server. And it includes as this platform a server module and a client module. And all those two components need is this 4DZ on top. And one of the other unique things is it delivers to the desktop native UI forms. So where we started in binary mode, which Jeff will take you through in a minute, we used to go through a great deal of human processes in order to produce that 4DZ file at the top of the screen there. But if you've never worked with 4D before, let me tell you that it is a platform. It's a platform very much like what we used to call mini computers, say maybe 15 years ago, like an AS400. Everything you need is in the box. That's it. Everything you need is in the box. So let's walk through this. I believe this is slide number 2. It is. So let me hand it over to Jeff and let him take you through the background of this environment.
Great. Here's a diagram that shows, it's a little bit simplified. It kind of shows the architecture of our system, our 4D-based system. The name of it internally is Symphony. Most of our users just call it 4D. We're trying to get that Symphony name kind of advertised out there because we want to really make it clear to all of our users that this is a homegrown application. This isn't something that someone wrote for us, that every line of code, there's about 1.4 million lines of code in this application, was written by Sweetwater developers for Sweetwater employees. So when we look at the core server, it's a single server application. 4D has told us that we're the largest single server deployment in the world. There's some bigger ones that use multiple servers. But as far as we know, we're the biggest on a single server. I'm going to request the screen for just a minute. And this is a live look at our main dashboard that we use to monitor this server's performance. So currently on the server, we have 1,096 users connected. It's been up for 13.78 hours. And right now we have, where did our process count go? Oh, we must have lost that. But in the middle here, you can see the activity of all the cores. And this is a massive server. This server it's an AMD EPYC CPU. It's got 128 cores. It's got a full terabyte of memory. And it's got just a ridiculously fast RAID array of SSDs. NVMe SSDs. So it's really about the fastest, most tricked out Intel architecture server that you can buy these days. And in fact, we have two at Sweetwater. We have one that runs production and one that runs as a mirror that's ready to take over in case of the hardware failure. So these are all different metrics that we use to measure the current health of the data file or of the server. So in the upper right, you can see disk activity. Below that, we keep count of all the failures of our web service transactions that we use with our integrations. We keep count of our most frequent queries. You can hover over any particular query and get a description of what it looks like. This one's a simple one, query inventory item ID equals something. You can look at some of the long-running queries and see what needs to be optimized. So here's a query that's running kind of long, query check underscore distributions dot check PID equals something. So this gives us good insight into areas that we need to optimize and that we need to look at. Simple finds, deep finds, these are user-generated queries against the database. And when I say we have a single server, we have sort of split this out now into a remote data store. So we try to point anything that a user could do into an external or a remote data store now, so that they can't really affect production. Users will come up with the craziest queries if you let them, and we decided to let them. So because of that, we give them their own playground to to do their worst and keep it out of the main production system. And order remote data stores are just a great way to do that. And you can see the rest of them are keeping track of the number of orders that come in from the web. How long does it take to create a web order on average? And the moving average, we try to keep it under 2 seconds. A few years ago, that average was 10 to 15 seconds per invoice. And with all the focus that we've done on optimizing our code, working with 4D professional services with their deep code analysis package, we've been able to bring this down to about a second or less, which is really tremendous. So in one glance, we get a nice look at everything that's going on this server. Okay, so back to the slide.
That view is such a tour de force of the entire operation, all the metrics of everything going on there.
Yeah, building in metrics is such an important part of really getting to understand your system. This application started 30 years ago. Most of the original developers are no longer at Sweetwater. In fact, I don't think any original developers are still at Sweetwater anymore. So we can't go back and ask them what they were thinking or why they wrote the code this way. All we can do is analyze it and get a picture of what's actually going on under the hood. 4D has really opened up in the last few years and given us lots of tools to get that information. There's lots of commands in the language that expose that. Of course, we're always asking for more, as Jim knows, but what we have now is really can give you a really solid look at what's happening under the hood. So we have 140 server. I'm not quite done there, so go back one. 140 server, and then looking to the left, we have batch clients, which are racked up in the server room or in virtual machines, just doing batch jobs. We have about 250 batch jobs that just run at various points throughout the day, 24 hours a day, 7 days a week. They just do their thing and no user interface. They just chunk through data. You saw the number of workstations. We've got about 2,000 users of the system. About 1,200 at a time is about the maximum that we would ever see on the system at one point. And then we
Do you
also
do
have
many, do you do many stored procedures, Jeff? Does your server run many stored procedures?
we have a few, not a ton of them. This application, for better or worse, is pretty trigger heavy. So there is a lot of trigger activity. One of the things we've been working on over the past few years is making as many of them preemptive as possible. And I think all but a handful of them right now are fully preemptive. So that's been a big job and a big improvement to our performance as well. So coming out of the server, of course, 4D is the source of truth for a lot of data at Sweetwater, but it's by no means the only system here. We have lots of other systems out in the distribution centers, in finance and marketing, and a lot of this data needs to be shared. The old way to do this was to write a batch job that would do an export or a web service call and just keep whatever system needed that 4D data up to date with its own private interface. What we've been trying to do now is take advantage of mirroring and the 4D journal file to provide this in a more generic way to the rest of the business. And the heart of this is something that James actually wrote. It's called Journal to Cloud. What this does, 4D Server is creating journal files, and the Journal to Cloud client takes that journal and converts it to JSON. There's a 4D command called log file to JSON, which is probably the most powerful command in 4D that nobody uses. Journal to Cloud, which is just a 4D application that sits there, converts the binary 4D journal file to a JSON file, does a little bit of, data redaction for PCI compliance, and then sends that data in JSON format up to Google Cloud. It's stored in a GCP bucket, and from there, an open source project called Kafka has access to all of those files. And Kafka is like a publish and subscribe system. So Kafka reads in all these journals, and then any other system that needs to access the data, they access it through Kafka, and they access only the data that they need. So they get updates as data changes in real time from the server through the JTC client, through Google Cloud, and into their particular application that needs the data. The beauty of this is that we no longer have to write all these one-off kind of customized exporters to feed different systems. If a system needs the data, all they do is subscribe to the data that they need. Kafka provides it to them in whatever language they're being developed in. And there's Kafka libraries for everything except 4D. And they can just pull that data and use it with absolutely no performance hit to the production server itself, because we are going to make journals to feed our mirrors over here. So creating the journal is no extra load on the system. We're just using that data to provide it to anyone else that needs it in a standard format using standard APIs. Excuse me. Another interesting thing in the flow, and this is all again using journal files, we send our journal to another one called Core Rep. We call it 4D Core Replication. This is a two-part thing. It has a tiny little 4D app that all it does is, again, converts the journal file to a JSON file. And then we wrote a C# application that takes that JSON file and populates every single 4D table and field in an equivalent Postgres database. Why do we do that? Because there are so many other tools out there for, for data analysis, report writing, all kinds of things that will talk to Postgres very easily, because it's a standard SQL database. So it's another way to feed data at no extra cost into a more standard format. Once the file gets converted to JSON, the C# application then updates our Postgres cluster with all of that information that can be combined with information from all of our other systems.
Does that contain all the tables in your 4D database and all the records and fields?
Just about all. We have the ability to customize it.
Wow.
There are some that make no sense to replicate into Postgres that are purely internal to 4D. But I would say most of our tables are replicated, probably at least 85%.
Yeah, it's just a little over 250 of the 600 tables.
Oh yeah, I forgot the table statistics, but I'll come back to that. So if you look at it, Core Rep and Kafka are pretty much serving the same purpose. So we have a project that's in late testing right now that's going to eliminate this Core Rep step in the middle here. And basically we're going to feed the Postgres cluster from the Kafka and Google Cloud repository. So there'll be just one path out of 4D server through JTC to Kafka that will then feed any application, whether it's Postgres or probably any of a dozen other applications in different departments that need access to that 4D data. And in addition to that, we have 3 mirrors. You can never have too many mirrors. We have 2 that are on site and 1 that's off site. And one of the offsite mirrors acts as an external data store so that, again, any of those end user queries or any query that can be done against a read-only server can use the ORDA external data store feature to point to the external, point to one of the mirrors. And again, an upcoming project is to throw a bunch of mirrors behind a load balancer so that we can move more and more of these queries, both in the application as well as the end user queries, over to read-only servers that are ORDA external data stores. So further reducing the load on the main production server. So that's the architecture of this application in a brief overview. Any questions on that? All right, next slide. And the last thing that I talk about when I talk about, what has changed at Sweetwater since I've been here. I've been at Sweetwater for 10 years now. All of you know what binary mode is. But when I talk to other developers, they have the concept of a shared code database that all your developers work on simultaneously. They can't fathom it. It doesn't make any sense to them. A couple of years ago, right before the pandemic, Sweetwater went through kind of a hiring spree, and we brought the number of 40 developers up to between 25 or 30. And that's really when client-server shared development really starts to fall apart. Anybody that's worked on a big project in a client-server manner, without version control, without source control, you know what I'm talking about. It's just, there's so many rules that you have to follow, so many procedures that you have to have in place that it really takes the joy out of software development. But we did it. We did it for a long time, and we made it work. Next slide. And this was our release cycle prior to project mode and CI/CD. And this is a virtual month broken up into weeks. And you can see out of the month, only the days in purple were available for developers to actually write code. The rest of the time was devoted to processes, just supporting the ability to take all the code that was written in those days, test it, document it, and get it ready for deployment. So the goal in binary mode for us was one deployment, one major deployment per month with what we called hot fixes in between. But if you look at it, 1, 2, 3, 4, 9, 10, 11, 12 days out of the month were all the developer had to actually write code. Um, the rest of the time, they either had to find a way to work ahead, or we provided other opportunities on other projects for them to switch over to. But it was really a limiting factor, especially you get up to 20, 25 users, what can be done in a single month. So that's when we decided to bite the bullet and go to project mode. James, all yours.
James, I think you're muted.
That is a classic problem. There should be an auto unmute button somewhere,
There you
right?
go. Yeah.
Yeah, okay. Well, I wanted to thank Jeff for giving us that background. The notion of deploying only once per month was one of the key drivers here. And when project mode stood up and became available, it allowed us to bring our Symphony application into the modern age. So all of those developers, all of the new people, and all of the existing people really had to learn a new way to work with this Symphony application. But it turns out it was kind of a moderate effort to transition from binary mode to project mode. It took some effort. In fact, there was a specialized team who went through the process of doing the conversion. But it wasn't. Let's just say it was approachable, and we got it done in the time frame that we expected. Uh, but that gave us full source control, in this case, Git, and we chose GitLab because it was being used in other parts of the business. And the huge benefit here is no more code freezes. So our developers could work 24/7 if they wanted to. Some of them did, I believe, in order to deliver value to this project. Hold on.
James, what would you say the biggest issue was in approaching project mode from binary mode?
What do I think the biggest issue was?
Yeah, thinking.
Yeah. Um, I think it was the forms.
Yep, yep.
Yeah, that was the crazy stuff. We still have some remnants of color manipulations left over, but I think it was the forms that was the biggest issue, along with the triggers. But
Historically, we didn't do a great job at really paying attention to what 4D warned us was deprecated. So we still had a lot of forms that were like group scrollable arrays used for used for printing.
yeah,
Something I forget the total number of group scrollable arrays the team had to go through and convert. It was something like 4,000 of them. But it was just crazy. And along the way, we took the time to add some logging, find out what was still used, what was no longer used. We were able to purge a lot of that old stuff out.
yeah,
But as 4D developers, really pay close attention to what 4D warns you is deprecated, and don't be lazy. Until I'll get to it next year. Because if you keep up with it, this kind of stuff would have been, at least for us, would have been a lot easier.
yeah, yeah. Okay, so if you recall from the very second slide, the primary objective is to get that 4DZ file validated and built, and to potentially be in a position to deploy that every day if necessary or when needed. So here's the plan. We had to, in the top left corner here, go through a process where we came to agreement with the developers as to what their daily cycle would be. How do you use these new tools? And the net of it is we asked developers to, following their Jira ticket, create a branch with their ticket name in it, create that branch against the current development branch in the main system, and then add their feature and function to validate it and test it locally on their machine, and then push that branch to the central repo. We do not allow developers to merged back to development or certainly merged back to main or release branch. That they create their feature branch, add their functionality, test it locally, and then they send that branch by pushing it up to GitLab. And when they do that, at some point when they're done, they create what's called a merge request. And that merge request is one of the triggers. So as we move kind of to the right there, inside of GitLab, when a merge request is created, we have GitLab execute a series of workflows to validate those changes before they ever get merged into the development branch, which is not quite the master, but it's one of the main. And and that's kind of where it stops. The just below the developer block there, you see a custom built release by QA. So QA actually tags the Git branch and says this will be release 1 or release 2 or release 3 or whatever. And when they apply that tag, GitLab goes through the full build cycle and produces a 40Z, which it archives into a facility it calls the package registry. So now I have a 40Z and all of the surrounding artifacts which describe what's in that 40Z and how it was built and what Git tickets were included in it. But that's all zipped up into one package sitting in the package registry. The benefit of that is the package registry and that file becomes a system of record. So for QA to finish their process, they would extract that or deploy that package to one of their QA machines, test it and validate it. And if they approve its contents, that can be deployed to production whenever they'd like to do that. And the key here is it's not possible to change the contents of that package once it's built. So if you're QA and you know there's 6 new tickets in here and you just said, okay, they're all good, there won't be a 7th ticket or any modification to that package. What you've just certified will exist forever and be deployable to whichever platform you wish. So that's where the job scheduler module comes into play. The job scheduler is really the QA team and deployment team saying, now that I have this new asset, when would I like to deploy it? And they can manually deploy it or they can have that deployment automated. In today's production environment, it is fully automated. We deploy mirrors at say 10:30 and we deploy the production server, the main server, and the main mirror at 12:55. And that's totally automated. But you see on the right where it says target platforms, those are all the platforms that we have in the environment. Basically development, QA, staging, training, and our production machine showing all of the mirrors that are in that tree right now for production, along with core rep and JTC. Now, core rep and JTC don't get the 40Z file because they're just standalone applications for the most part. But because they also get journals, there is a pipeline that handles building the journal management program, which when we move journals from one machine to another, we're using kind of a mutual certification SSL or TLS kind of encryption to ensure that there's no security exposures on the transport of that journal file. Those journal files, in some cases being binary or JSON, we want to make sure that if there was an infiltration, that they wouldn't have access to what is essentially our core data. Some of us developers, which I shouldn't say too loud, I guess, when we need to rebuild our local test data file, we do that by processing a few journals. And of course, it just rebuilds everything as the standard nature. Now, the bottom left corner here in this plan, yes, we made the effort to get to project mode. Now we've got the developers creating their own feature branches. But how do we pull off this notion of there's a 4D server sitting there running, and the first thing we'll have to do is shut it down orderly, as opposed to just walk up and press the power button. So we need to shut that machine down in an orderly fashion, and then we need to launch it. And then in the terms of the pipeline, as a merge request comes in, we want to take a look at the changes in that feature branch and say, is your syntax okay? Did you change the structure? Did you add an index? We have a feature, an APM feature out of Datadog that basically tracks every method and the time that method took to run and who it called and the time it took for that called method to run. But we have a map of the execution of most of our major modules. And we call that APM, and there is a special function that we wrote in 4D called method metric end. Just quite a mouthful for sure. But you don't want to have this APM feature do a method metric start without a method metric end. Otherwise, everything from now on in that process is going to get captured until you run out of memory and take 4D server down. So we have a specialized check called a method metric end check that checks to make sure that there are matching statements inside of these methods that are in your feature branch. So that list of Symfony operations, orderly shutdown, foreground launch, because the way Gitlab works, it puts a module on all of our Windows servers that run the 4D server code and or the JTC code, and it runs in the background as a Windows service. And so if you want to launch 4D from that background service, it just doesn't happen. So we've written a couple utility programs to listen to the background service that live in the foreground. And when the background service, or essentially GitLab, says start 4D server, it basically launches it from a foreground standpoint. We use an IPC kind of channel to talk between those two programs to get that thing launched. All right. So that was the plan. And as we move a little bit further, this is what we had to actually add into our Symfony 4D application. We added a listener or worker for orderly shutdown, and we do that by placing a file on the desktop, literally called orderly shutdown.json, and it has a couple values in it. It has the message to send out to the users, and it has a timer. It says, wait 30 seconds and tell all the users that the system is shutting down in 30 seconds, please log out, right? And if it happens to be a mirror that's in the middle of digesting a collection of journals, we break that loop at the appropriate spot so that we don't lose track of which journals we're at. Before having this orderly shutdown function, the only way to do it was to go in and kind of press the button. And if you're lucky, things did it properly. If not, you spent an extra hour at night when you're doing the update. So the orderly shutdown was the key feature. The foreground launch, I think I've already mentioned that the GitLab runners run in the background and they're not able to launch a foreground application. So we wrote just a couple short Go programs that do that, if you will. Component changes. We started out, I think when we first went to project mode, we did that at 19. And then we went through the series of 19s and then 20, and now we're up to 20.2. As you make those transitions, your components change and your plugins change and the versions change, right? And if you've ever copied something from a Mac machine to a Windows machine where you run the server, you know that majority of the time it doesn't work when it lands. So we kind of have a off-screen repository where we keep the versions of plugins and components for every platform with a hash code. And if we notice that our deployed target has a different hash code than what our repository, we download and install new plugins and new components for that machine. To the point that if you go up to a 4D server in Sweetwater and you delete the components directory or the plugins directory, the next deploy will repopulate it with the current set of plugins and or components as required by that particular machine. So that was one of the ways that we handle going from one version to the next version of 4D.
James,
Just to add a little bit there, the problems were really with the notarization of the plugins and the components. Depending on the path that those component or plugins take, you can lose that notarization info that's now required in order to get a smooth launch. So that's why we had to go through some extra hoops there to get that all to work correctly in a cross-platform kind of way.
Yeah.
Question, Jim or James. You're not making a built server application and a built client application?
No.
You're still using 4D to build a regular 4D and 4D client to launch with a link to go back to it. Because the normal 4D way is built application, replace the whole damn thing every time, but you don't do that. You're just replacing the .4dc and maybe components and plug-in folders if necessary.
And resources.
And resource. Interesting. Why don't you want to go build application?
So we've looked at that. 4D wants us to. We have a lot of infrastructure that kind of replicates a lot of what a built server client would do for us. It's kind of on the roadmap now that we have the I forget the name of it, where you can basically replicate the user environment through that new web interface. I'm drawing a blank as to what that's called, but that will make it a little easier for us to do that. We are an in-house application, so once in a while you do need to go into the back end and make a couple, data changes, but it's mostly a matter of legacy and history that we don't do that. It's on the roadmap. It's not the highest priority. And it definitely did add a few extra steps here that we wouldn't have had to go through if we did have a built application. So
I think you're referring to the Data Explorer.
yeah, that thing.
Yeah. I'm a big fan of the built client server environment myself. Just like you were saying earlier, it's important to quasi brand the application to say, this is our baby here. This isn't, everything 4D can do, for one, because 4D can do so much else. But this is our home built application called, in this case, Symphony. We did have one more question. I don't want to get you guys off track. I think it was answered in the chat, but I just want to give you an opportunity to answer it in the presentation. How do you manage to get Gitlab to build the 4DZ file without running it on a Windows or a Mac machine?
Yeah, great question. I don't know. Let me just peek here, see if I got a chart that deals with that. Yeah, I do coming up.
Okay.
The answer is when you implement GitLab or even GitHub, you have a choice between building on the GitLab machine or building on a local machine. And if you build on a local machine, the word for that is self-hosted. And in order to get a commander to talk to a consumer, you need to put on that consumer a piece of code called a runner. So in GitHub, there is a self-hosted runner. In GitLab, there's a self-hosted runner. It's basically a command channel between the central GitHub and that local machine. So on a self-hosted machine, you install the standalone 4D client. You install in this case, the GitLab runner. And when GitLab says, let's do a workflow, it sends a command down to that Windows machine or that Mac machine where its runner's at, and it tells that runner, issue these commands. And today you could use Tool 4D as the executor in the 4D context, or you could use a full-blown client. For us, we're using a full-blown client because we are using plugins, and Tool 4D and plugins had a problem at one point. So that's really the kind of command channel, which we'll hit to in just a moment. And so it is headless and it is kind of disconnected. So back to the path here, we talked about plugin changes last, and the next one there is a health check. So inside of the Symfony 4D code set, we added another worker that's called health check, and it listens for a UDP port so that when this headless operation from GitLab says start up 4D, how would we know that it started? And when we're having this discussion, when I said, hey guys, to the folks who do it nightly, how do you tell that things are good? And the conversation went on past 45 minutes. And I'm going, okay, so how am I going to do this, right? So we came up with a health check that basically just grabs the number of session and the registered users. And if it's more than one, for the most part, right now, that's good, right? Because when you grab the sessions, you can see how many of our batch clients might have came online. There's no real prescription for which ones have to be there necessarily. And for the registered clients, the desktops and or the batch machines, again, there's no firm prescription. That's all human intuition to determine if things are good. So we wrote this health check, which is a UDP service inside of 4D, that at the end of the deployment process, after everything's done and we've said launch 4D, we sit and wait for 120 seconds, and then we say, are you there? And of course, if it is, it answers the health check query with a blob of JSON data that describes the number of users, things of that nature. And we know at that point that we're good to continue. All right. So that's the health check component that we added so that we have that visibility that it did start and it is in a functional state. I mentioned method metric in. Everybody knows what a syntax check is. The structure change is something special. That's a 4D class that I wrote to examine, because we have Git, I can examine the main branch and the current branch and decide, did you add an index? Did you add a field? Did you delete a field? Did you add a table? Did you remove a table? And if there was a structure change, that would be information that we capture, because in this context of production servers and mirroring, you want your mirror to always be up to date when the structure's in place. But do you need to deploy to the mirror every single time you deploy to production if there is no structure change, right? So we needed the visibility of that. And we also wanted the feedback to the developer to let them know you changed the structure, and I hope you intended to do that, right? And we do the same thing for an index change. Now, because we have core rep out there, you've seen that from the earlier slide, core rep sends data to a Postgres database. If our 4D structure does change, we need to update the schema in that Postgres database. So when we see a structure change, we actually, using another 4D class that we wrote, generate the DDL to update the Postgres database that this change just occurred, right? And then finally,
how does the Postgres database get updated? Does it have a command to ingest that DDL that you created, or does someone have to go in and manipulate the Postgres structure and add tables and fields and indexing?
well,
I don't know. If you don't know, that's okay. I just
no. The answer is it's all humans. Humans do that. We have a data engineering team that we send that over there to. Now, your point about do we have an automated path? I was just about to create that, and I kept looking at this thing called core rep and the JTC Kafka thing, and I'm going, wait. Why am I doing this? Right? I mean, the Kafka stream can get it all done. So that's why we have a project in place to make core rep go away, right? Is it removes some of those burdens. So rather than write the extra code necessary to automate that path, we just said, hey, let's just clean up here and get rid of core rep because we have a much better alternative. But could have easily have done that. It would have been a little quirky, but we could have easily have done that. And then I mentioned the package registry at the very bottom. That's not a 4D app. That's a GitLab app, but it's significant to point that out each time. So what does our code look like? What do these classes look like inside of Symfony when we did that actual tooling? Basically, on startup, we call a method called has user parameters. Um, and then we call a command factory. If I just even breathe on this mouse, it moves. Okay. Um, then we have a command factory that basically there's a class for the structure change, a class for syntax, a class for compile. Um, there is a class, well, I didn't, it's just a method, I guess, for orderly shutdown because that's a worker. And then there's a class that generate the SQL from a structure change. And those are all basically commands against this command factory, which just makes the implementation a little bit cleaner for us and a little bit easier to read. So this is essentially the collection of stuff that we needed to write in 4D to manage the notion of shutting the server down cleanly, bringing it back up, acknowledging that I'm up and operational, and that these are the environmental changes which we need to communicate to different stakeholders who work with the Symphony app.
Now, to add one little point here, one of the really one of the great things that happened as a result of all this is that when you submit a merge request, and remember, we have 25 developers that are working in 4D all the time, might be a little less than that now, but a couple dozen developers that are writing code and submitting new code. We never ever want our development branch to be in a state where there's a syntax error or something that would cause it not to compile, something that would break the build. So one of the great things that 4D added a while ago was a user parameter when you launch 4D from the command line to run a syntax check. So with every merge request that gets submitted into Git, we trigger a GitLab runner to launch 4D with the check syntax command. And the merge request is going to fail if there are any syntax errors that are detected by 4D. And that's really a key part of this whole process. And I just wanted to point that out. It really saves a lot of time for QA and also back and forth from QA to the developer.
Absolutely.
Are you using 4D tools on GitHub to do the syntax check?
No, we use self-hosted runners. And
okay, you're doing it yourself. All right.
We use self-hosted runners and full 4D clients.
Okay, gotcha.
And we have two machines set aside called build servers that are dedicated to the syntax check and the compiles and those operations. The so-called production machines or environmental machines like dev, staging, what have you, yes, they have runners. They could do that work if necessary, but we use those runners only for deployment purposes. We have two separate machines set aside just for the build operation, so to speak.
Yeah,
I imagine it takes more than
virtual.
a few seconds to build. I imagine it takes more than a few seconds to do a syntax check or a build of 1,000,000 lines of code.
Syntax check is usually less than 15 seconds.
Really? Wow.
Yeah. And a build is like 20 minutes, maybe. Yeah, it's 20, 25 minutes or less.
That sounds about reasonable, 25 minutes.
Yeah. Yeah. So, there's a lot of arms and legs around this notion of automating, working with GitLab and things of that nature. And you can do all of this through, screen clicks on a browser directly to GitLab. Like you can go look in the package registry, find something and say, I want to deploy this somewhere. But that's kind of a hassle if you do that every day, all the time, right? So we wrote just a quick standalone app in 4D to help our QA team schedule a deployment. So this screen here basically shows that they can go to the package registry on that first list box, choose a release, and then in the middle list box, choose the version of that release in case it got released twice in the same day. And then kind of on the environment on the right side, choose the machine they want to deploy to. And that's all filling out the dialog on the right side of the screen, and then choose a time and date. And when they hit the create schedule button, it adds an entry into the active schedule list at the bottom. And GitLab will automatically, at that date and time for that runner or for that machine, deploy that version of the release. So no more screen clicks. It's basically 1, 2, 3, 4 clicks on this screen, and they've scheduled a release for all of the production machines or just one machine. Now, that's how we started out as the first phase. It's like we were still doing screen clicks. But once we got comfortable with it, hey, this really works well. We don't need to have humans doing the schedule. Whenever we create a release, we can do an automated schedule. This app became not necessary anymore. So it's about to get modified for a different purpose. But today, when QA says, I'm ready to create a release, and they apply a tag to the Git repo, we automatically create those schedules in GitLab to say at 10:30 deploy to the mirrors and at 11:55 deploy to production automatically. So we could see inside of GitLab those schedules being set up.
And it's also a great example of a 4D application running in dark mode. So
Yeah.
Would you use this also if you installed a version and then, ooh, this is a bad one, we need to go back to the previous version? Use this to point to the previous version and make it reinstall that?
Yeah, you can install any branch, to any machine, but I should show you a GitLab screen that basically says GitLab knows all of its runners and what kind of machines they're on because we put a tag on them called the environment, right? So it keeps track of what was deployed to each one of those environmental machines. And I could go back to, well, we have this kind of big toy called an engine because of all the car people, right? And when you screw up production, you get this engine on your desk as a trophy. Right now I have that trophy. I told Derek that I'm not coming in, so he can't give it to me. But right now that trophy's mine. But what happened is we deployed something to production and said, "Ooh, we got to revert that." So the reversion is they went to GitLab, went to the environment, and said for the production machine, redeploy the last successful deployment. And that basically rolled it back. And all of that takes probably about 10 minutes to do a full deployment. Shutting it down, deploying the new 40Z, starting it back up again, waiting for it to start, and then verifying that it did start. That's like 10 minutes or so, right? And hopefully we don't do that very often. Most people who get the engine keep it for lots of time, right? All right. So
I want to jump in because I need to leave this meeting. Super interesting. I love all this. I've been writing 40 since 1990, so it's been a long time. I'm curious how you capture runtime errors. Do you gather them and then send them somewhere so they can be reviewed?
Runtime's errors are outside of the automation aspect in terms of GitLab, but we have 3 or 4 different mechanisms. Primarily, they're all targeted to capture that error, capture the call path, capture the method names, and send it as a record to Datadog. Our Datadog is our dashboard manager, our log manager, our process manager. I mean, I think you might know what that is. But we capture all of those errors in the various error handlers and all log it to Datadog under a different kind of ID or service ID. And then we have dashboards over the top of it.
So with Datadog and 4D's new universal error handler, which is just a tremendous feature, we're now finally logging every single thing that happens, and suppressing the UI from the user. But by sending it to Datadog, Datadog can then generate alerts or correlate it with other events that are happening platform-wide and give you the data that way. So having a logging platform, whether it's Datadog or anything else that's available out on the market, is really important for these larger deployments.
Yeah, we're talking about 4D automation directly in terms of just getting it deployed and started and managed from a quality standpoint. But there are three other layers surrounding this installation. The data logging layer, the alerting and or Ops Genie kind of layer, as well as a separate performance layer that surrounds that. That each of those layers would take the same amount of time to walk through. I mean, you don't get the kind of dashboards that Jeff showed earlier that could actually show you which queries by name are taking too long. How long does it take for a certain critical process like web order download to actually occur? The instrumentation that we have in place that feeds these external systems from my view, there's at least three more layers out there. This was the critical piece of actually getting the package built, certified, and deployed without human intervention. And this is what we're talking about today.
But really, your question brings up a nice integration that we could think about for the health check. Since we are logging every single runtime error to a central place, part of the health check could be to see if we have a spike in runtime errors after deploying a new version.
Yeah.
It would probably only detect the stuff that's happening on a batch client or an automated client because these happen at midnight or in the early morning hours, but it'd still be a good bellwether that, there's something could be suspect with this build.
Well, now we have access to all these data sources and can work through those. And in the context of GitLab and its automation capabilities, it basically sits there and says, if you trigger me, I can run these operations on any machine you wish. And so far, our only triggers are basically humans saying, create a new release, or humans saying, do another merge request. But in fact, we could take advantage of the automation in GitLab to drive some command operation on one of the machines. So we could run a trace analysis program, or we could run a data compaction program on any of the machines that are part of this automation window.
No, it's great stuff. Thank you very much. I did not know about Datadog, so
Excellent.
appreciate it.
Excellent. All right, so I've touched on the majority of these topics, but I did want to say these were some of the things that we stuck in GitLab to support these operations. And I mentioned before the pipelines, and I'll touch on that again in a moment. And you see now the Datadog integration for activity logging and alert enablement. We also connect into Jira, our ticket system, so that we know what tickets are in a particular build, and the GitLab package registry, where we have all of the built 4DZ files for the last 90 days. And we have control of, do we keep things for 90 days or do we keep it for a shorter period of time? But these are some of the capabilities that we put inside of the GitLab environment using GitLab direct facilities. And I mentioned in the top center screen where we have the ability to deploy 4D components and or plugins because we keep track of what version of those assets are on each of the runner machines, and we can manage that on a running basis. We talked about earlier the development cycle for a developer. This is kind of a high-level view of how a developer interacts with this system. And for the most part, a developer's role is to take a new ticket, create a branch that reflects that ticket's identity, add the feature function into it, do their own testing, and then submit a merge request to the system, and it is managed from there. Our QA team merges those tickets after they've been code reviewed and approved into the development branch, and then they make releases from that. So this is essentially what the developer's insight and view is, unless they want to go in and say, I wrote my features in a interpreted branch and tested it interpreted on my local machine. Can I compile my branch and deploy it to my machine, or download that package and run it on my local machine? And of course, the answer is yes, and we provided for that. these were kind of the deliverables from the overall project. And I just mentioned the release process. The release process includes two key features for each developer, if they choose to do it, to actually build and compile any branch or to deploy any branch. Now, the deploy, in some cases, you can deploy to our stage or development platform, but you could also just download that asset from the package registry and run it on your local machine if you have a local server, right? There are artifacts at each step. If there's a syntax check failure, we tell you which module, what line number, and what the statement was that has that syntax check. That's an artifact that occurs with every single job that's out there. Notifications, as we're going through the pipeline doing these different operations, if there's a structure change, we send a message to our Teams channel to say, hey, for this particular build, there's a structure change. So anyone who's interested in structure changes, like our data engineering team or our data warehousing team, they have some visibility as to which release specifically has a structure change. And yes, that job that ran, that noticed a structure change, has an artifact that says this is the table in the field and or the index that has the altercation into it, as well as we send emails out. And just recently we turned on a monitor inside of Ops Genie and Datadog that when we do a deployment and we get a good response from the health check, we send out a message that says deployment status success or deployment status fail. And if it says fail, then that starts a cascade that ultimately sends a text out to whoever's on call to come take a look at that. The bottom of the screen looks at what some of the high-level workflows are. I mentioned, I guess, early in that first overview chart that there's something that's doing distributions. And that something is called a journal producer and a journal consumer program. Those are little Go routines, little Go applications that basically grab the journal from the server and register it to a Postgres database. And the consumer basically checks that database to say, is there anything new? And if there is, it asks that server to download it. And that's fully encrypted. But there's a pipeline that builds that little program should we ever change, or, it's a TLS enabled app and we have to change its certificates every year for some reason. But I think that's our internal security policy. But we have to compile that program every year and then, of course, put it on all the machines where it would be needed. So there is a workflow just for journal distribution. When we do these commands via runners and things that will start 4D or do a syntax check or whatever, all of those commands, whatever they are, we could have, kind of a batch file or a script statement inside of 4D not 4D, but inside of a GitLab that would execute each of those things step by step, or maybe use some kind of GitHub action. But instead, one of the differences between GitHub and GitLab is that GitLab allows you to use whatever language you would like for those steps in your workflow, where GitHub encourages you to use the GitHub Actions, which are JavaScript kind of modules, if you will. So originally we wrote all of our steps using Bash, then we use Bash and PowerShell, and then we use Python. And I love Python as much as I love Microsoft, so we had to get rid of that. And so now we wrote a Git program, a Go program, Golang, that basically you just call our CI tool and you pass in syntax check, and it will tell 4D to do a syntax check, or it will tell it to do a compile, or it will tell it to do a health check, whatever. So you can see the high level things inside of our GitLab workflow, but the actual commands and tooling we've embedded inside of an executable program that runs on Windows or could be compiled to run on Mac at some point. So that's our CI tool. And the only time that pipeline runs is when we change it for some reason, right? When a merge request happens, you see That's the workflow left to right, along with the compile any and deploy any. And then at the bottom, this is our release workflow. And what these workflows are is they're separate streams of commands that are awaiting specific triggers to get fired off. And when they do, they perform their work. So I think in terms of GitLab triggers, like when should I do this? Well, I'm going to do this when someone makes a merge request. I'm going to run the syntax check. And the merge request will be denied if the syntax check fails. And also I need to run the no method metric check. And I need to run the structure check. And I'm going to do that when a merge request is created. How will I know that a merge request is created? Because we have protected and turned off access to the main branch and the development branch. And the only way to change those or merge your work in is to go through a merge request. So everybody has to play by the same set of rules. Okay, wrapping it up. Yeah, we started out with deploying once a month. We can now deploy on demand anytime we wish or on a scheduled basis. The developers that used to stand down for 7 to 9 days because we were going through these human processes no longer have to do that. So they have a huge productivity increase. The QA team, which had to force the developers to stop working so the code would be stable enough from the test and certify, have a huge productivity boost now because of this capability. And those poor night owls who were kind of really working second shift to do deployments to the production machines nightly or on a periodic basis, now they don't even have to worry about it because they'll get an alert if it should fail and they'll get to sleep if it's successful. That is the output, if you will, of this 4D automation effort. And again, we're just talking about the narrow path that says, as developers, let's write some code that has value for the business. Let's build it and certify it. Let's protect it. And now let's deploy it so that the business can extract that value. And if we do that in a proficient way, we can, in fact, stabilize the community that we work in and the business that we work in because they can trust this deliverable. And as a result, the business's time to value has been tremendously increased. Now, if we had some new business thought leader say, here's a new strategy that's going to move the business forward by $1 million a month. In the old system, it would take us 30 days to deliver that function. In this system, we can deliver it this afternoon. That's the kind of difference that this kind of automation makes. And it's not a big deal to put in place.
And it really elevates the role of QA also, which is great to see. You know, a developer just has to worry about their feature. They submit their feature, and then it's up to QA for organizing the deployment of that feature, or if needed to pull that feature and roll it back. So it really makes their job, a lot more satisfying. They're in control of their own environment, which is great.
All right, any questions?
I got a couple, James. I always have questions, you know that. Do you guys ever see a syntax check succeed, but the compile fail?
No.
In the past, many years back, that used to happen. But you're not seeing it now, so I haven't seen it for a while. But I used to see that every once in a while. You do a syntax check and it would work, but then you do a compile, and compile would sometimes spot things syntax check didn't. I haven't seen it for a while, so I wanted to see if you guys have seen that because you got a lot of code and you're doing a lot of changes. That's good to know. How do you handle structure since everybody is now running their single user copy of 4D on their machine with their own data file and they're making changes? How do you handle they go in and change a table or a field? and somebody else, you know, the problem where if everybody doesn't have the same data file, the catalog.4D catalog file gets corrupted.
Yes.
How do you deal with that?
We that's a great question.
4D's answer from Thomas Mall said, we just make every developer have the exact same copy of the data file, and then we don't have the problem anymore. And I said, that's a stupid answer because sometimes you need another data file to test something out. But how do you guys handle all these developers making structure changes and the catalog.4D catalog file not getting weirded out by different data files?
Okay, so one, we don't care about the data file that developers using. They can have their own unique data file. However, there is only one catalog.4D catalog file, one structure file, and it is in our Git repo. And if you touch it or change it, everybody gets that change. That's why we look for the change when you push a feature to the central repo. That's why we look for a change to see, did this feature branch include a change to the catalog file? We want to know so that we can let those other people know that that occurred. But yeah, there's one catalog file and it's a part of the repo like any and everything else, and it's synchronized along with, those capabilities.
But I've got the catalog file on my machine. I go into my version and I add a field or add a table. And then when I push up my changes, up to Git, the catalog.4D goes up.
Yeah, those changes sit in a merge request until someone does a code review of it and QA says, okay, I see you made this kind of change and we agree that this feature and functionality is appropriate, right?
Okay.
And then GitLab says, could I actually do a merge successfully of this thing? And if it can, then the merge occurs. And when that merge happens, that feature moves to the development branch, which all the developers typically start their day by pulling down the development branch and ingesting it into what they're working on. So
is that your workflow? Each day,
a,
developers pull down the current dev branch and integrate it into their current branch?
Yep. Yeah, that's the workflow. And if doing that were to produce a merge conflict, then the pipeline itself would say that that has occurred. So if I just grab one here, again, my mouse just loves me for some reason.
Because people using Git with 4D, and they're just the only developer on the project, don't run into this. But when you get into a real project with 4, 5, 6, 10, 20 developers changing structures, fields, and tables, gets a little bit more complicated in project mode.
Yeah, that's a Git workflow issue. So, for example, if you make a structure change and I make a structure change, whoever gets there first gets the master catalog file, and when I rebase, then I have to deal with the conflict on my side, and I don't get the next field. I get the field after your change, so I have to then, when I do a rebase, that I get the second one.
See how complicated it is? He had to go through all this stuff, and all I did was add a field to a table, okay? And now we got to do all this extra stuff. I hope they fix this in the future, because right now, structure changes with project mode in the team development mode, there's some issues to it. And we didn't talk about the data file issue, but I'll drop it and let people move on, because that's something that I've got to deal with. But I just wondered how you guys handled it. And I like the idea that every day developer workflow is bring down the current dev branch and merge into what you've got, so we can see if you start your day with something that's broke or something that's, oh, everything's fine, I can keep working.
Yeah. And you only have to do that, Tim, in the timeline where you believe you're finished. So, it might take you 3 days to work on something, and you don't have to grab it every single day. There's no rush there. You just need to do it at least once before you declare that you're finished and you want this to go forward, right?
Okay, I understand. Okay, I understand.
Yeah. So I mentioned something about pipelines. This is a merge request screen and artifact. And
I stole the screen share from you. If you want to go ahead and initiate the screen share again, whoops.
okay,
I'll let you control there.
I'll put it back there.
Yep.
Hopefully that you can see that.
Yep.
All right. So let's go back one screen. This is a merge request screen, and you can see some of the steps here. It says merge pipeline, because you are in a merge request and you submitted a change, there's going to be a pipeline that does syntax check. And so if we look at what that pipeline does, here I can see that there was a syntax check that was performed. There's a job log that tells me at the end that the job was successful. But over here on the side, it says, hey, you want to browse this artifact? And inside of the project directory where we keep the artifacts, you can see there's a Symfony CI dash check syntax result JSON. And in that file, if there was an error, that file would tell me what line and what method and what the statement was that caused that particular error. The other thing someone mentioned about deployments, inside of Gitlab, which is where I am, I can choose one of the machines or environments, and I can take a look at its history. What was deployed, what was successful, what failed. And if I go in and take a look at one of the jobs that are here, you can start to see some of the console logs of the things that went on. Basically, we say we're talking to a GitLab runner. It's our tool that's running. We're going to check out the code. We're going to go through a series of steps. We're adding the Datadog logger so we can write the completion code. We're checking that the Kickstarter, which is what we call that launch program, we're checking that the Kickstarter is there and running. We send it a message that says, hey, here's a command, start the 4D server program and use this particular data file when you start it. And then we go down the steps where we waited for some period of time and we ask for a health check. And this is the response from the health check where it basically says, yes, I'm here. I have 0 users, but 16 tasks. And here's some of the stored procedures and registered users I have in place. And we're done. There's also artifacts with this kind of deployment operation as well. But let me step back to really close this up. I want to show you what a pipeline actually looks like. So let's go to a pipeline editor. This is the pipeline editor right here, and this would be the default pipeline where it says, we hit visualize, yeah. This would be the default pipeline where it basically says, let's just declare some variables and secrets, and we're going to go through the build stage. And the first stage is check syntax. And in order to check syntax, run this script. Check out the code, run our tool, and then tell our tool to do a check syntax, and then list out the directory. If I could go back, say, 40 versions of this, that would be, a bunch of command line commands that you would type necessarily on your command line. Here, we've embedded all that into an executable that we can manage. Okay. And then this is what the project tree looks like. There's a CI directory that has all of our automation commands in it, and you recognize the rest of these directories. And if I were to go to build pipelines, you can see on this screen here that here's a pipeline that's running right now. It's most likely just a check syntax that's running, yeah. But you can see there's only one dot here in the stages of the pipelines. But if we click through here to where they have built a a new release, like here, you can see there's 4 dots: a check syntax, a notification stage where we notify a bunch of people like Jira and things of that nature, where we go through a build, and then we set up a scheduled deploy. And if I go over to pipeline schedules, you can see the schedules that are set in place and what release and targets they're going after, and where they are. The next run, basically, we leave the schedules out there, and every night we overwrite them to say, okay, do this again, but use this new set of values. All right. That is really everything from an automation standpoint. The only thing you haven't seen is that all the code for the workflows and all the code for the few Git root or Go routines that we use. But I'm around. You can always ask me. Those things were trivial. They'd be pretty straightforward to do.
There's
Command Factory class that James wrote is just really, really slick. We're already over. I don't know if you want to show any of it or not, but if anyone's interested in classes and how to write a correct class in 4D, you should have a look at that.
Let's see, I can show that. It's not a project method, it's going to be a class. And let's see. I think I'm still sharing the screen, yeah.
Yep.
Yeah,
so let's go for the check syntax command. Command factory, and maybe the generate SQL. All right. So this command is the check syntax command. And you see it starts out by saying class extend CI command. So there's a template somewhere that kind of sets the standard for this. And here's my class constructor where we call that template. We set up a timer. It has one entry method called execute, which is actually something the template demands, and it returns the status object. So I can call any command just by instantiating it and then calling it its execute method, and it'll do whatever it's supposed to do. In this case of doing a syntax check, it basically says, let me create an options container, add an empty collection into it, start my timer, and then call the method called check syntax with those options. And 4D has a command called compile project that if you send it an object with an empty targets collection, it will just do a syntax check versus compile the whole thing. So, and you can add a few other options to kind of set the type of syntax check, like a strict one or a loose one, those kinds of things. But here, that's the work that gets done. Whatever the result is, we capture those results and return those results as a part of this method. And that's what gets written out to the results file that you saw that artifact came from. Now, you notice I'm capturing application type here because at one point I would try to use tool 4D, and what I noticed at a certain version of 4D, like version 20.1 or something like that, that application type returned the wrong value when tool 4D was being used. And that kind of prevented things from running. So I basically am now documenting what application type does, but it's not necessary. It's just me being a little anal, I think, to say, this thing burnt me one time. I'm going to track it forever. from now on. So that's the command that does the work. And you can see if this folder, if the compile actually generated some errors, I'm capturing those errors and writing those out to a particular Symfony errors.xml file so that that's available. It depends on how serious the problem was. We talked about that class extending the CI command. A command for all of the programs is simply this. A constructor which says there's a method called get commands, there's a method called get project name, and then there's an execute method. And they're just dummy methods for the most part. But because a class extends them, they have to implement these methods. Otherwise, you're going to get the dummy results, and it'll be pretty obvious why that failed. If I move on to the so-called command factory, inside of the command factory, it basically says, when you call me as a command factory with this method called get command, you call get command with the name of the command that you want, and I will instantiate one of those objects and return them to you. So I don't ever have to tell the users what the name of the commands are or how I implemented them or what the parameters are. When they call command factory get command syntax check, we're going to look at the keyword, and if I know it, I'm going to instantiate the syntax check command or the structure change command or the compile and build command. I'm going to instantiate one of those and return it, or I'm going to return null. And if I look at this is the generate SQL command. It's not in the command factory directly because it only gets called if the structure change says the structure change. So it's the structure change that actually makes a call to that. But it has the same, pretty much the same mechanics. Now there's one caller. There's a command here. Let's see. CI. Okay, so I have to touch it. CI handle. CI handle user params. I also talked a lot about health check, didn't I? So that's an easy one. CI health check. This is the health check method. It's just a short method, 62 lines long. It's a few lines shorter. And for the most part, all it's going to do is listen on a particular port. And when it sees the word health check, it's going to grab the registered clients, get the process activity, count of users and tasks, build up a JSON file, and send that JSON file back to the user. And if a consumer of this health check wants to, they can check, well, you're not good unless you have 10 users or more, or you're not good unless you have X number of processes, or you're not good unless you have these specific processes, right? So we send them back the information to do that evaluation for the most part. So that's it for a health check. I mean, kind of an open, a receive, and a write. And we're sitting there listening for it. And the health check only occurs during deployment time. I would not advise calling health check as a normal query of a production server, especially not in our case where we got 1,200 users. I mean, that data block coming back would be in the megs. If you've seen the output of some of these commands like sessions. So I wanted to touch on this CI handle users parameter because this is the guy that listens to the command line when 4D starts and then does all of the operations. And it basically says, log to the system console that you've started, look at the user param that came in on the command line. And here we're just using the word compile or whatever. I've seen other people use an actual JSON object that's been stringified as the user value, since you can only pass one value. So they pass a stringified JSON string, so they can pass an object of parameters in. I'm just passing one word at this point, but you see the preamble here. Basically, it says, call the command factory to get an instance of it. I know I'm going to use, I need to use whatever this user param value is. So go get that command. And every single command, I have to check the structure check to make sure nothing's changed. So we're adding structure change as a command. We're getting a command for that as well. And then we just walk through the work. This does everything instead of including compiling. It just calls the classes. So you see it's only 61 lines of code in total, including saving the artifacts. And this is the point here where if we look at the result and we notice that the result includes that the structure change, that's where we call the generate SQL class. We execute it, capture its results, and write that output so it can be used for the downstream people. I mean, there's lots of layers here, if you will, but any questions so far?
In the chat, Jeff posted some stats for application. 14,000 project methods, 26,000 total methods. Does that mean you got 12,000 classes? Is that what that is? Or 12,000?
No, like form methods and stuff.
Okay, so you got 12,000 form methods.
Object methods. Yeah.
Object method. Oh, and that's object methods too. Okay, wow, that's great.
All right. I mean, I could show more of the classes or things of that nature or the Go code.
Let's save some for another round because this is awesome and there's clearly more awesomeness to show.
Yeah.
Yeah, thank you so much, James, for showing that command factory.
Yeah, no, it's very elegant.
I think I have that command factory implemented on my GitHub page.
Oh.
I'm pretty sure I do. Let me see if I can just point that out as an ending comment.
I think you have the build tools in GitHub. I don't think command factory is in there.
Let's see. I think I might have it. It's going to be github.com/SKOONA. Yep. And forget what I called it. 4D Explorer. In 4D Explorer, if I go down to project, sources, here we are, first one, classes, yeah. There's a syntax check, the command template, the command factory, and the compile and build. So,
Nice.
4D Explorer, I get the URL of that, and I can put that on the chat.
So you guys mentioned earlier on that originally you made these slides for another purpose, and obviously there's just a wealth of best practices and impressive management of your environment. How was the presentation received, by the other parties?
I'll answer part of that. There's some kind of friction between the 4D developers and these JavaScript developers or PHP developers or web developers. There's something going on in between the two. I poked them as hard as I could possibly do it without physically touching them, right? but they thoroughly enjoyed it because they didn't know that 4D had everything in the box. They didn't really understand and have a structure to position 4D. It was just this ugly language compared to their language statements. But once they started to hear and see that there's a task scheduler, a process scheduler, that there's native forms, that, there's a database, there's an object relational model, that there's, HTTP and TLS and other capabilities, that there's OAuth, that all these things are in the box, and all you have to do is be concerned about the function that you want to do. You don't have to figure out runtimes, and you don't have to figure out fancy libraries and all of this, right? They received it very well. I mean, that was, part of what my second chart here, that was me trying to figure out how can I depict this in a way that they might be accustomed to seeing it. Because we just call it 4D, and maybe once upon a time it deserved that slap in the face, but not anymore. I mean, and I made this point in the presentation, we are the only application server in the place. And oh, by the way, we run the place.
Well, a lot of times when you talk about 4D to people that don't know 4D and it's a database application, they go, "Oh, it's like SQL Server." Okay, well, that don't do nothing. SQL Server, you got to pile all this other stuff on top of SQL Server to actually get it to do anything. And then they don't realize, well, by the way, 4D gives you all that stuff. And then they go, well, it must not be any good because anything that's all baked into one product is all stripped down and not fully implemented. Until you look at it and find out there's, 1,500 4D commands now, 1,500 different 4D commands.
Mm-hmm.
Yeah.
You want to add something to that, Jeff?
Expand on that just a little bit. So James started with Sweetwater, 3-4 years ago?
Yeah, about 3.5. Yeah.
Yeah, and I would say I would put you in that same group as the web developers and the non-4D developers in your perception of 4D.
Yeah. Ruby, Java, enterprise Java beans. I mean, yeah, I was the bigot, that's for sure.
And if it's been a real evolution watching James go from someone that just didn't understand what 4D was all about to someone that can actually champion 4D, and with his, experience at IBM and other, really large corporations, for him to be able to expound upon this to people that don't have any idea what it is, it shows the real transformation that took place and really the power of the platform, in my opinion.
Well, sometimes a newcomer has the best perspective to be able to, translate this environment into, the rest of the world, of application development.
And really, until recently, there have been some huge roadblocks to doing that. I mean, without source control, without to, have CI/CD and automated builds and without classes and object-oriented design patterns, it was a really tough sell to anyone that, comes from a computer science background in the last 15, 20 years. So,
well, that's why I asked. It's a common discussion I think all of us have had at least once in the past.
And I came from the same background that James came from. I started out on IBM System 36 AS400, writing RPG programming and COBOL, okay? And that's the way it was back in those days. You bought into the IBM environment, their mini computer, and they gave you everything. They gave you the hardware, they gave you the software. It was all in that box, and everything you needed was in that box. And if it wasn't in that box, you wasn't going to do it, okay? Whereas 4D, if it's not in the box, you could actually write a plug-in to make it do what it won't do. But I remember coming to that too. And so 4D environment was nice because it's just one thing you have to learn, and it gives you all these pieces, You don't have to build, I got to learn this, 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 I got to install that, I got to install that, I got to install that, I got to install that. A lot of people, that's their life. You know, they go, well, I'm going to have to spend a day installing all these packages and then I can start work. Whereas with 4D, you install the app, get the documentation, start working.
Yeah. The one deployment app you saw that I showed the dark mode screen of, that took me about 3 hours to write, and it has 12 different API calls to GitLab in order to get the list of contents of the registry, to get versions, and to create, the various things necessary. I mean, I took about 3 hours to do. Now, that's because I'm familiar with it and because of the new kind of list boxes we have that support collections, right? I mean, if you do it, it's impressive. And this notion of time to value, which is really one of the most critical metrics a business can use, is from the time that you have an ideal for an improvement, how long does it take to deliver it? And if the answer is 3 months or 1 month, that's the wrong answer. And with 4D, that can be the same day if necessary, in many, many cases. That's the pivot point that I use the most, is I think through this notion of time to value, and that's how I choose the tooling. 4D supports that very, very well. Yeah.
It looks like you have a lot of best practices to share with all of us, and it must have offered a tremendous amount of sanity to the development efforts at Sweetwater, putting all of this in place and organizing the various steps and automating what can be automated. So huge, yeah, wonderful.
Yeah. So for anyone who wants to repeat it, GitLab has a ton of education. None of these things are difficult. You can start out one step at a time. It's possible to do. And if you have a very small project, you could probably get it done in less than a month. But you need to decide to do it and just do it, because everything you need is right there.
All right. Well,
We'll be quiet then.
James, Jeff, thank you guys so much for all of your effort. I know that you're both very busy and obviously have other things going on in your life, and it takes a lot of time to set aside for these kind of efforts. And but boy, is it a wealth of knowledge that you're sharing with the community. So thanks again, and thanks to everybody at 4D for helping us out in another one of these meetings, sharing information with us. And thanks to all of you for taking part in the meeting and all the recent ones and ones to come, hopefully. And yeah, other questions, there's a dedicated forum post for this, and questions can be posted there or directly, obviously, to the team at Sweetwater. And you can always support the group via the Patreon group user group link there, patreon.com 4DMethod. It's always appreciated and helps to make this stuff possible. So, all right, until next time, I'm gonna end it there. Thanks again, everybody.
Thank you all.
Thanks, everybody.
All right.
Thanks, James and Jeff.
Thanks.